Okay, today I will show you guys how to find the block ranges when you're doing subnetting for IPv4. We're going to start with one of the examples, 192.168.253.224/30. So this is the way I do it, and I think this is the easiest way. Then we will do the theory behind it. So we get the IP. Then we're going to find which section of the octet we need to translate. So this is going to be the last octet. So 224 to binary. Then we translate /30 to binary, and we do an AND logical comparison. And we get, of course, 224 as the network address. And then we get the wildcard, which is the inverse of the CIDR. In this case is .03, and then we translate it to decimal, which is .03, and we add the network address plus the wildcard, and it's going to give us the broadcast address. So we have the network address, the base of the network, the wildcard. We add the network plus the wildcard, and it's going to give us the broadcast. So now we know the ranges between the network and the broadcast. And if we add +1, it's going to give us the next network address. So now we can simply do 4 in this case, +4, and it's going to give us the next network address. So it's usually the wildcard +1 is going to give us the next network address. Now I will show you the theory behind it. So we have the base .0, and of course we now know that is +4. So 4, 8, 12, 16, blah blah blah. So the theory behind it is /30 has 6 bits of the network. So we use the formula to find how many subnets we're going to have. So to the power of the subnet, the bits. So 2 to the power 6 is going to be 64, and now we know that there is 256 options from 0 to 255, so that's 256 options divided by 64 subnets, and it's going to give us 4. So that's the theory behind it. And remember that the last number is 255. It starts at 0 and goes to 255. So now we have another example. 10.168.181.56 CIDR 25. So we know it's the last octet. 56 to binary. Then we get 25 to binary. We make logical AND comparison, which is 0 in this case. And we get the network base. So now we find the wildcard, which is the opposite of the CIDR. We translate the wildcard to decimal, and we add the network plus the wildcard, and it's going to give us the broadcast address. So now we have the network baseline plus the wildcard. We get the broadcast address, and +1 is going to give us the next network. And this is a very simple one, because the last option that we have is the broadcast, which is 255. And I will show you the theory behind it. So we have the first network address, the second one, and the last is the broadcast, of course. So /25 has 1 bit. So we need to find how many subnets we're going to have. As you can see, we're going to have 2 subnets. And we know 0 to 255 is the options that we have. So 256 options divided by 2 is going to give us 128. So we're going to use 128 to find the next baseline of the network. Another example is /15. So this is the third octet. We know the deal, so we're going to translate oh, I mean the second octet. We're going to translate to binary, make a logical AND comparison. In this case, we're going to get 26. So the network stand at 26 at 0.0. We're going to find the wildcard. In this case, it's kind of big, but it's just the opposite of the CIDR. Then we're going to add the network plus the wildcard, and that's going to give us the broadcast address. So we have the network plus the wildcard is the broadcast. And the next one is the network address. So now we know that it's +2. The network address for the other one is 30, 32, 34. Now the theory behind it. So we know it's 222. And theory is /15, so that's 7 bits. 2 to the power of 7 is 128. So we divide 256 divided by 128, and the sum of the ranges is going to be 2. And we saw that. That's it. See you.